Good morning and good afternoon to our global audience. And welcome to all of you to today's webinar, which is our final installment in a series of 3 webinars. And our topic today is UVC Air Purification Basics. My name is Andrew Hull. I'm the head of marketing for UVDI, and I have the pleasure of introducing the webinar today. We're really excited to review the fundamentals of UVC air purification by both sharing some basic concepts and common questions, and most importantly, hearing your questions about this important topic and the utilization of UVC technology to achieve it. Before we get started, I would like to share a few webinar logistics. Today's program will be recorded so that all of your feedback is captured. During the presentation, you will be automatically muted and your cameras will remain off. In order to share your questions, please do so using the question box, which is located on the right side of your screen. If you've been on our previous webinars, you'll probably notice that the interface has changed. GoToWebinar has upgraded their platform, but if there are any technical issues that come up as we're going through the presentation, please type these questions into the question box, which is, again, on the right side of your screen. Note that we will be covering the answers to a number of those questions in the final section of the webinar, and we'll be sending out additional notes afterward. Note that the webinar, again, is being recorded and that we will be providing it on our website on demand within about a week after we complete the webinar. Also note that the 2 other previous webinars in the series on air disinfection and another on coil cleaning are also currently available to watch. And now, to get started, I would like our moderators to, I'd like to take the chance to introduce our moderators and let them introduce themselves. So first, we're going to turn to Dave Heidel. He is the UVDI Director of Global Airside Sales. Dave.
Well, thank you, Andrew. Thank you. Welcome, everybody. Especially welcome you, all of you coming in from across the globe, as Andrew had mentioned. I'm Dave Heidel, the Director of Global Sales for the Airside Group, and I do want to welcome you on behalf of the entire sales team. Andrew mentioned the question function. We want to do a quick test on that. So what I'd like you to do in the question box, type in where you are coming in from, your city, your state, your province, your country. Want to make sure the question function is operating. So please submit a question with your location. All right, we have Christine in Texas. Albany's in the house here. Albany, Texas again, Florida, Orange County, Pennsylvania, Fort Worth, Anaheim, Tampa, Indiana, San Francisco, Salt Lake City. Okay, well, it looks like it is functioning. I'm glad to see that. As Andrew mentioned, today's webinar is all about furthering your comfort with UVC purification. To do so, my colleague, Dr. Ashish Mathur, is going to address some of the common questions that you've shared about UVC and its utilization in air purification. Then, true to today's town hall format, returning to you to capture and address your question. And for now, I'd like to turn it over to kick it off to Dr. Ashish Mathur.
Hello, everyone, and welcome to this third webinar in a series of 3 webinars focusing on UV technologies and solutions for disinfection and air purification. My role at UVDI is I'm Vice President for Innovation and Technology. I've been here for 15 years, having fun with UV. And I've had the opportunity to work with 2 leading organizations who are focusing on UV. One is the ASHRAE organization, where I just rolled off as chair of the UV Technical Committee. I'm also on the board of the International Ultraviolet Association, and I'm currently facilitating or leading an industry working group looking at what are the gaps, what are the learnings we have today, and what standards and regulations and research which needs to be done in this field. So with that, I'm going to kick off this presentation, and just give me 1 second. Okay, Dave, can you see this okay?
We see your opening slide, the
All right,
UV
thank
purification
you.
basics.
Okay,
There we go.
I'm on to the next. All right. So yeah, as we all know that there's been an increased focus on indoor air quality over the past 3-4 years ever since COVID. And before COVID, it wasn't that much in focus, but there has been an increased focus for multiple reasons. Of course, pandemic has been there, but global warming, climate change has really changed the way we behave and how much time we spend indoor. So of course, there are more and more people spending time indoors. Temperatures outside are hotter. So and as a result, and also with this whole tech revolution, focusing on computers and Zoom meetings and everything is done indoors. And of course, our kids and teenagers are working more on their phones and laptops all day and playing less outside. So, and then the third thing is with more and more gadgets and everything inside buildings, the pollutants which are inside the building are also higher now. Of course, we still have the outdoor pollutants. We have the smog and now wildfires and everything affecting our indoor air quality. But in addition to what's outside and what's been pulled inside the building from our HVAC system, there's also a pretty high generation of pollutants inside the building. And then, fortunately, the government is taking an active role in this initiative, and they have, over the past 3 years, there have been numerous activities by the government. I think it started with the White House Summit on Indoor Air Quality 2 years ago. That kind of kicked things off. The Clean Air Buildings Challenge, all that has really impelled and increased the focus on indoor air quality across the board. So our learning objectives today is we're going to review what are the sources of air pollutants, particulate gases, which would be VOCs, odors, and other gases contaminants, and then of course infectious aerosols like the SARS-CoV-2 is one of them. Then we look at what are the air purification technologies which are used inside the air handling systems, inside the ducts which are feeding all the buildings, as well as localized in-room solutions. This presentation is focusing more on UVC air purification solutions. And people who haven't attended the previous webinars, they're still available on demand. We had an on-demand town hall format webinar on coil cleaning, followed by another one on air disinfection. And this one is focusing more on VOC, odor control, and room air purifiers. Then we'll talk about benefits of air purification in general. And then we'll go over what are the current ASHRAE standards or industry standards related to this topic. So now as we get started, we'd like to start with a brief poll to learn about you and your experience with air purification technologies in general, not just UV, but in general. So I'll let Dave run this poll for us. Dave?
All right. Thank you, Ashish. We're launching the poll here. The question is, are you currently using or specifying air purification systems? And if you can answer, I'll give you 10 or 15 seconds to respond, and I'll close out the poll, and we will see what the results are. And there's going to be a follow-on question that's really going to get into types of air purification systems that you might be involved in. So I see the poll's running. We're getting a lot of responses in. And we'll go about another 5 seconds or so, and then I'll close it out and we'll see the results. Okay, I'm gonna end and share the results. Everybody should be able to see the results. We had 69% indicating yes, and 31% indicating they're not currently using or specifying air purification. Thanks for your responses there. I'm gonna close this out. And Ashish, if you can pull up the next slide, we'll do the follow-on question. All right, so this is going to be the follow-on poll. What type of air purification technology are you using or specifying? We had a pretty large number from the first one that indicated they were. So if you can please select once I turn this poll on, and we'll keep it open again for a period of time. So please let us know what type of air purification technologies you are currently using or specifying. And I see the results coming in. Thanks for your responses. We'll give it about 10 seconds, 10, 15 seconds, and I'll close the poll out and share the results. Okay, I'm going to end and share the results. Everybody should be able to see. We had 71% indicated MER 13 or above, so very common air purification. We do have a percentage with ionization, our PCO technology, UVC, and others. And so it'll be interesting to see what other technologies, and we get further into it. You feel free to type those into the question box, and we'll track that. So great, thanks everybody. Appreciate responding to this poll. We're going to have a couple more throughout the presentation. I'm going to close out and turn it back over to Ashish.
Thanks, Dave, and thanks everyone for participating in this poll. This is a town hall style format, so we would like to keep this interactive. So as we go along this webinar, please feel free to add any questions you may have in the Q&A box. So just a recap of what are the sources of indoor air contaminants. Of course, we have stuff coming in from outside. There's a concern of smog, wildfires. The outdoor ozone levels are also pretty high in a lot of areas, and more so in densely populated cities and urban populated areas, as well as agricultural areas. And then inside the building, as I mentioned earlier, there's a high source of contaminants. Not so much particulate, but a lot of indoor air chemistry related challenges, volatile organic compounds, which could be emitted and off gas from carpets, furniture, even people, plants, pets, and what have you, paints, and photocopiers, inks, laser printers. So there's a whole source of VOCs being generated inside as well. So when we take a look at what are the different types and sizes of these pollutants coming in, this slide is showing you the relative sizes. So when you start with what's visible to the naked eye, that's really, I would say, the size of your hair is around 100 microns. So this range is in microns, which is 1,000th of a meter. So your hair is about 100 microns, and then it's visible to the naked eye. When you talk about your general dust and pollen, those are in the 10, 5 to 15 or higher range. When you start looking at moles, when you look at microorganisms, moles are the biggest in size, more in the 1 to 10 microns. Then you have a bacteria ranging all the way from 0.3 to 10 microns. When we talk about smoke, smoke has both particulate and VOCs. So the particulate portion of smoke, whether it's fumes, whether it's oil or tobacco, they are a pretty broad range. It can be as low as a 0.1 micron and as high as one or even higher particle sizes for smoke. Viruses are, of course, much smaller in sizes, and they're typically 0.1. SARS-CoV-2 was right in that range. But when we talk about VOCs and gas molecules, they are really in the angstrom, or like 1,000th of a micron range. And VOCs, odor molecules, they all come in this range. So when you look at this whole chart, you can say, okay, is there one solution which can fit all? And of course, the answer is no. You do have HEPA filters, which are considered probably the best out there, and they do a fairly good job in trapping everything in this range. But when you start getting down below 0.3 micron, that's where we have the trouble and challenges. So this slide is something which I've shared in the past. There's a whole lot of microbial contaminants which are growing inside the building. Some of them, of course, coming from outside. If you have plants outside your building, they're coming through your intake. But whether it's a cooling coil in your duct, all these microorganisms on this list have been identified inside the building. Bacteria and fungi, of course, are there in your ducts. You might have heard about sick building syndromes in the past. That's when they've done a lot of studies figuring out what are the microorganisms found there. And of course, viruses, SARS-CoV-2, influenza has been, the flu season is what we're talking about, influenza adenovirus, that's prevalent all over the world. TB continues to be a big issue, especially in third world countries, Africa, and there's a heightened focus from the World Health Organization and UN on TB. And we've heard about measles outbreaks also happening. We've heard about Legionella also outbreaks. When you look at indoor air chemistry, there's a whole range or types of contaminants inside the building. The volatile organic compounds are the smaller compounds which have a low boiling point, as I would say less than 50 degrees Celsius to 250, high vapor pressure, so they volatilize very easily and they can disperse all over your building. Even your microbes, microbial contaminants, of course, we have the microbial challenge and they can infect, but they also emit VOCs. We call them microbial VOCs. So they have their own emissions of alcohols, ketones, and acidic things, and they also have a smell, as we all have seen. And there's a category of indoor air chemistry related challenges called semi-volatile organic compounds. These are heavier VOCs which tend to be heavy and they can actually get deposited into the ducts or into your buildings or on your floors. And that's a challenge, and people are recognizing that this is something which needs to be grappled with, and there's a lot of research and activity going on in this field as well. Ozone, of course, continues to be a big issue. Ozone levels outside the building are high, and there are EPA limits what should be there, and then ASHRAE has a guideline on how much ozone can be allowed in a building, and they recommend putting air purifiers to reduce the amount of ozone. But ozone does get inside the building as well. Plus, it can be generated inside the building as well using from photocopiers, laser printers, and there are some air technologies which are used, which could also potentially generate ozone if they're not designed properly. So common VOCs found in buildings, there's a whole list here. Limonene is a common one. Toluene is another one. Formaldehyde, of course, is a toxic related issue. Acetaldehydes are also there. So most of them are related with smoking, cleaning solvents, and carpets and everything. So this is just a handful, but the list goes on and on. When you put things in perspective, all these chemicals, you have to look at it two ways. There are some chemical compounds which you can smell very easily. For example, hydrogen sulfide, really low threshold of detection, even if it's far away. Or you think about a skunk smell. You're driving past and you can smell it from a long time. But is it really toxic to you? Does it have a health effect? So this column, the second column, is basically showing the threshold limit value from a health standpoint. So there are some chemical compounds which have a low threshold of smell. That means you can smell them pretty easily and quickly. But the hazardous limit is much higher. So this is the ratio of detection limits to a threshold safety limit. So there's a whole range there. So something which smells bad may not be harmful to you at those levels which are there in the building, but then it's a big perception thing. So you have to recognize these things. And then the HVAC system is also a culprit. Of course, there's so many things which are part of the HVAC system. There are sealants, gaskets, caulks, adhesives, and of course we have filters. The graph on the right is from a study done at Lawrence Berkeley National Lab, where they actually looked at filters. Filters typically capture the contaminants coming in, right? But they're not destroyed or anything. They're just growing on the filters. And they also have been shown to emit VOCs. So what you see here is a graph where it shows that, okay, there were some filters which emit formaldehyde and some filters which show acetaldehyde. Some of them are fiberglass based, which have thermosetting resins and other chemical compounds and binders. And then there are some polyesters, cotton polyesters, and they have tachyfiers. So all these things can also emit VOCs. I don't know if you can see this, but there's a study here which shows emissions from all the different components inside the HVAC system, and of course these are your main sources. You have coatings, you have lubricating oils and filters. So it's not just the VOCs coming from inside and outside, but even in HVAC system, things which are used inside can emit. So this time to do another poll. Dave, can you run this poll again?
Yes, yes, Ashish, thanks for giving us an introduction, talking about the challenges that we're facing inside of buildings. So this poll, what we'd like to do is uh, learn from you a little bit more about your reasoning behind using certain solutions. So question would be, what do you identify as the main concerns which would require an IAQ mitigation solution, air purification solution? And when I open the poll up, please select all that apply. All right, it's launched. So what do you really see as your main concerns? And responses are coming in. We'll go about 10 or 15 seconds, give you a chance. All right, 5 seconds, 4, 3, 2, 1, good. Right, I'm going to end and share the results. So it looks like pretty high level responses to all. We look at particle with a 79%, odors 55%, indoor air chemistry VOCs, the gaseous 55%, viruses at 84%, and then bacteria, mold, fungus at 89%. All right, thanks. I'm going to close the poll out and turn it back over to Ashish.
Right, thanks everyone. So let's get into some of these control strategies which we use here. Oh, sorry. So as we all know, source control is of course the first line of defense. If you can't control your source, that's what you should be doing. And then of course in your buildings, ventilation and dilution is okay. Either you bring in more fresh, clean outside air, or you can exhaust it as well. So ventilation, dilution of the contaminant load is of course your second line of defense. And then you have air cleaning and disinfection solutions. And as we talked about, particle reduction, microbial control, VOCs, and odor. So it's not really one solution. You really need to apply a multimodal approach to basically control and have the best indoor air quality. So when you look at the different technologies which are applied today, I would categorize into, I would say, 5 different buckets. Fibrous filters are, of course, the most commonly used. When you look at for which contaminant are they effective, I've broken this down into particulate, biological, and gaseous. So as we all know, fibrous filters, the mode of capture or mode of filtration is capture. Of course, the biological particles, which are bigger than what the fibrous filter can capture, there's some capture there. But like I said before, the viruses are much smaller. And unless you have a really high HEPA filter or something like that, or even higher ALPA filter, you would be able to capture that. But viruses would typically go through the fibrous filter and it's all captured. And fibrous filters typically don't do anything for gaseous contaminants. And then you have a category of electronic air cleaners, precipitators. The way they work is they would stop the particulates, they would agglomerate them, make them bigger in size so that they can fall out or they can be collected on a collection plate and can be removed. Same way, particles in the air, biological particles can be charged particles, negatively, positively charged, and they can also stick to each other and they can grow in size and they can fall off the airstream or get collected by the electrostatic cleaner or precipitator. Ionizers also, they have the same kind of mechanism. They rely on the ions being able to interact with the contaminants, the charged contaminants, and they would again agglomerate, neutralize them in some cases, and also take them out. And there's been some effect shown for gaseous contaminants as well. UV technology, on the other hand, does not do anything for particulates. And of course, this is a big yes for biological contaminants. And of course, it has been shown it's a really powerful technology, and it does have some effect on gases contaminants as well. But it's not been studied a lot. But we know through some limited research studies which have been published that there is reduction of VOCs. We do know that UV is very effective in destroying ozone, so that is very well known, and it's been used in the water industry as well to remove ozone in the water stream. Activated carbon is a tried and tested technology for gases contamination only. And depending on how that activated carbon filter is made, it could stop particles as well, but not typically designed for that because the pressure drop will go up. But activated carbon technology and zeolites and what have you will be very effective for gases contaminants. Photocatalytic oxidation, or PCO, is also a technology which has been studied heavily. Doesn't do too much for particulate, but there has been enough studies which show that it's effective for removing biological loads and definitely for gases contaminations and VOCs. So primarily to remove VOCs, and there has been an effect for PCO. And we'll get into a little bit more detail here. So time for another poll. I think as we get into, we're drilling down into UV applications. So let's wanted to hear from you on what your experience has been with UV for air purifications. Dave?
All right, thanks, Ashish. Yes, as Ashish mentioned, he's going to be really digging in deeper behind UVC air purification. So I wanted to get a sense from the audience on, what solutions are you currently using? So when I activate the poll here, please respond, and then we'll take a look at it. All right, we'll go another 10 seconds. All right, good responses coming in. I'm going to close out and share the results. So the question again is, do you currently use or specify UV-based solutions for air purification? Are you, let me see. Are you able to see the results? Yes, I'll have a little technical difficulty here. I'll go back and read the results if you can't see it. Yes, they're installed in my facility at 14%. Yes, my company specifies UVC for air disinfection at 40%. Company uses UV-based solutions for odor control at 4%. We're not currently use or specify, but interested at 34%. And not really certain what's going on in your facility at this point in time is at 8%. So it looks like a large percentage are using a number of different types for meeting challenges that you're having in your facility. I'm going to close out the poll and turn it back over to Ashish.
Thanks, Dave. So moving on, focusing on UV. So based on the poll, we know that people are pretty familiar in applying UV for coil cleaning, airstream disinfection. But there are several applications and experiences which people have with in-room disinfection, where the lights are mounted on the ceiling or mounted on the wall, which is 254. And then you have the upper air solutions, which is just focusing and disinfecting the air in the upper part of the room while keeping the occupants safe in the room. Photocatalytic oxidation is activated by UV. That's why it's on the list, and it has been shown to be very effective in reducing gases, contaminants, VOCs, and odors. And there's a whole line of portable air cleaners which uses UV in addition to all the other technologies. And there are air cleaners which use UV for disinfection and photocatalytic oxidation as well. So talking about UV a little bit, just a summary of what we all know, what are the main benefits of UVC technology compared to some other solutions. So of course, UV is a low energy alternate, and I would say an adjunct to particle filtration. I think you need to remove all the particles first because UV is not going to do that. But beyond that, it's a low energy alternate to Of course, it's a green technology. Filters load up and they have to be disposed of, whereas UV, all you have to do is change the lamps out, uh, depending on which lamp you're using and what the system is. So it's a green, sustainable solution, and it supports all the decarbonization initiatives which are being going on. So it really fits and feeds into that. The primary mode of mechanism why UVC is so popular and works and endorsed by CDC and a lot of studies is that it inactivates DNA and RNA of pretty much all microorganisms. So of course you need different doses as we talked about in previous webinars, but it does a very good job in inactivating all microorganisms. It's a proven technology for coil and airstream disinfection. It's been known to destroy ozone. So I was giving the example of water applications. There are some UV lamps which also use 185 nanometers wavelength, which emit ozone to clean the water. And then what they do is they install a bank of 254 nanometer lamps downstream of those lamps to remove all the ozone which is generated from those ozone producing lamps. And so it is effective. It is well known that it removes ozone as well. Of course, it is highly effective, but it has to be designed and applied properly. It's easy to maintain and implement. Of course, low lamp energy consumption. Again, depending on your size of the system, the energy draw of these lamps is very low. And of course, the other advantage is that these lamps really have pretty much no pressure drop add-ons to your system. So just a review of all the technologies which we have. Coil cleaning is of course the most used because we know that the coils get fouled, they have bacteria growth, and then there's a challenge in heat transfer coefficient, pressure drop, and other things. And UV light is installed downstream or upstream of the coil. More downstream is recommended because it can also get the drain pan. And then over a period of time, depending on how much UV you've installed and how dirty your coil is, it gradually breaks into the fins of the coil, even if the coils are 6, 8, 12 inches deep, and over a period of time, it can make your coil pristine clean and make it work to its design efficiency. And of course, the added benefit to IAQ is that it increases your heat transfer efficiency, so it improves your energy efficiency. It decreases your energy consumption because your coil is not fouled. Your lower maintenance costs, you don't have to throw in chemicals on a regular basis and pull the coil out. And of course, from another sustainability standpoint, there are no manual chemicals or aggressive chemicals used. Air disinfection has been used in two different formats. One is inside the central air handling system, where you have a bank of UV lights inside the air handling system. It can be combined with coil cleaning so that you get the benefits of both coil cleaning as well as air disinfection. Or if you want to just focus on certain areas of the building, you can install the lamps inside the ducts or inside all the ducts. Of course, you need to recognize that the air velocities inside the air handling system is much lower, like 400, 500 feet per minute. Whereas when you go inside the duct, because of the narrow size of the duct, you have a much higher phase velocity, and you would need to apply a much higher dose of UV to disinfect the moving air. Again, there are common airborne microorganisms which have been identified, and it's effective again. So I've just listed some of them. Of course, the whole coronavirus family, influenza. So typically before COVID, even today, influenza has been the most commonly chosen microorganism to design a UV system because compared to SARS-CoV-2, influenza and adenovirus and influenza virus requires at least twice the amount of UV dose to inactivate. And tuberculosis needs even more, and so on and so forth. And then we have, I was talking about local area or in-room disinfection. You have the upper air systems where the UV lamps, UV fixtures are installed only in the upper part of the room here, and it's disinfecting the upper air, whereas while keeping the occupants safe. Of course, these have to be designed correctly, and they've been known to be very effective, Primarily before COVID, upper air systems have been used for tuberculosis, but since COVID and the higher focus on infectious or microorganisms, upper air UV is now being touted and applied for general purpose, not just for TB. Then you, like I mentioned, you have ceiling mounted fixtures. There are some new technologies out there. These are called 5 UV lamps, which are relatively safer compared to 254 nanometer lamps, and they can be installed in ceilings or mounted on the walls. There are guidelines. So like I said, UV is a tried and tested technology, has been endorsed, is proven. ASHRAE has some guidelines on what is your recommended dose or intensity you need on a coil. Of course, you have the advantage of a static surface. It's a static surface, and it's you can build your dose over a period of time. If you want to know more about dose and how it's applied, you can go back and look at the previous on-demand town hall meetings which we had. Same thing for air disinfection. ASHRAE has really laid out the guidelines. They said, okay, for SARS-CoV-2, you just needed, say, 611 microjoules to get a 90% inactivation. Whereas for all general purpose, they recommend a dose of 1500 microjoules, so which is more than twice. Like I said, SARS-CoV-2 from a UV standpoint is very easy to inactivate. So generally, when we design the systems, you don't want to pick the lowest hanging or the easiest to kill. You want something which is a system which is robust and be able to inactivate a wider range of microorganisms. So let's get into UV photocatalytic oxidation. Some of you may not be really familiar with this, how this technology works. It is a highly effective air cleaning technology which combines UV and a titanium dioxide photocatalyst to disinfect. So you have all these contaminants, VOCs coming in, and the UV light is shining on a photocatalyst. Titanium dioxide is a readily occurring catalyst, and then all these VOCs are converted into harmless carbon dioxide and water. That's really the basic principle. And most of these PCO solutions can be integrated into a design inside your air handling system where you can have a bank of UV lights with photocatalyst around the UV lights to get activated. So the mechanism is, again, it's oxidation and it's catalytic. Catalytic means the catalyst does not get used. That's really the advantage. When you think about your car catalytic converter, it's converting all that engine exhaust into harmless CO2 and water in your car. But it's a high temperature application in your car. The catalyst is a noble metal, palladium, vanadium pentoxide, really expensive catalyst. For indoor air, primarily titanium dioxide is readily occurring. This reaction occurs in ambient temperature, so you don't need high temperature, regular temperature, and it's basically what it's doing is it's as the catalyst is activated by UV technology, it converts these, and you need, of course, the moisture levels inside the air handling system is enough to be broken down into these really powerful oxidants, which are hydroxyl radicals and superoxide ions. Very powerful oxidizing reactions. They're actually even more powerful than ozone. And what these do is they would interact with all the VOCs and convert them into CO2 and water. So it's tried and tested. And NASA was one of the first, of course, I would say government organizations which used full PCO in the space. And that was really used to remove ethylene from the plants which were growing in the space station. Because in the space station, we had all these plants and or whatever fruits, vegetables, and the ethylene would ripen them fast and destroy them. And they were using PCO to increase the life of those plants and vegetables. So like activated carbon, people who might know that activated carbon is considered a universal adsorbent, and it takes out pretty much everything, again, on a relative basis. Some compounds are easier to absorb or remove. Some compounds are more difficult, depending on the size and the chemistry. Like I said, it's an oxidation reaction, and every chemical compound has a different reactivity to oxidation. So there's several studies on PCO. This is just one snapshot of a study done by Lawrence Berkeley National Lab, where they showed that you can have single pass removal efficiency all the way up to 85%, and in some cases it's 20%. So, and this is your relative oxidation rates of different chemical compounds which are occurring. So it does a good job. Again, if you're looking at single pass, maybe don't expect a 95% removal in a single pass. Like activated carbon technology would work for that. But when you're thinking about a recirculation and you're removing odors which are lightweight and your concentration levels are not so high, then PCO technology is a really effective technology in removing these things. It's not trivial. It has to be designed and applied correctly. The catalyst type, and these are all nano catalysts. The size of the titanium dioxide is right. How that catalyst is applied to the carrier is important. What's the surface area? You need a really high surface area which can be activated by the UV wavelength. And then what is the overall UV flux on the catalyst itself? What is the wattage? And again, this is uh, another technology which has been studied a lot, is being applied for water purification as well as for air purification. Of course, there's a law of diminishing returns. You can't just keep on increasing intensity and get more. The way you would do it is you would increase the surface area. So you could do it by having maybe one module or more than one module of the PCO catalyst to increase your residence time for activation. And of course, there's a relationship between the contaminants, like I showed in the previous slide. Different contaminants have different oxidation rates, and your phase velocity and residence time all factor into how effective your PCO system is. And the other advantage is depending on the catalyst which is used. One catalyst we use is a honeycomb catalyst, so which does not really add any pressure drop to the system. Again, the advantage of a catalyst is it does not need to be replaced on a regular basis. It has a fairly long life, into, let's say, 3-5 years if it's been maintained properly. So benefits of PCO, efficient removal of odors, VOCs, and gases contaminants. There are energy savings through reduction of outside air. If you're just bringing in outside air to remove your smell, then of course that's not advisable. Your energy consumption is going out. So you can add a PCO technology in your air handling system, which will remove your VOC and odors. Negligible pressure drop. The other advantage compared to your car catalytic process, this is ambient temperature. So, and of course, green technology, chemical ozone free, minimal maintenance requirements. Just to compare, activated carbon is a universal adsorbent. It has the highest surface area available for any technology, has really high capacities. If you're looking at really high single pass removals, that's when you would want to use an activated carbon technology. So I showed you this picture. I'm just going to skip this since I've already shown this. And let's talk about room air purifiers. There's been, again, during COVID, there was a big focus on what can we do? What about schools and all? They were all grappling with what is an easy, ready solution to inactivate. And they were focusing more on bioaerosols and COVID. But room air purifiers, if they are designed correctly, and they can add a multiple of technologies. You can have a pre-filter followed by a HEPA filter. You could have activated carbon in there, UVC for air disinfection, and of course, photocatalytic oxidation. So you would find a whole range of room air purifiers in the market, but you have to see whether it's a certified HEPA or they're just making claims that it's 99%. And sometimes you want something which does a bit of everything. The advantage of room air purifiers is that they really work well in a recirculation. Don't expect very high single pass removal rates. Of course, if you have those air purifiers are going to be bulky, big. They probably have a high noise level. So because of the application, there's a compromise on how powerful a fan you can put in, and at the same time try to pack it with all the technologies you can to get a fairly good job for air cleaning. CDC has recommendations for portable air cleaners. ASHRAE has recommendations for portable air cleaners. So I don't want to get into it, but yeah, so it's EP also has something. So talking about some standards and guidelines which are there, focusing more on ASHRAE. Today there is no, I would say, a code for indoor air quality. There's a Clean Air Act, which is like, I think 40, 50 years old, but it only focuses on outdoor pollution only. And it has been shown that the benefits to do something to comply with this Clean Air Act, the benefits to cost ratio is 3:1. And we believe, the ASHRAE industry believes that the same thing applies to IAQ solutions. If we do have an indoor air solution, the health benefits far outweigh the cost of implementing an IAQ technology. The 62.1 standard uh, does something. It's not the best for indoor air quality because it has a fairly uh, let's say loose definition of air quality. Says as long as 80% or more people are satisfied with the solution, then that's all you need to do. You need to do a survey and see if people are happy with it. If not, then you need to do something about it. There are some procedures involved outlined in the standard. There's an indoor air quality procedure which helps you apply your air purification solution. There's a ventilation rate procedure, which is more about ventilation, not about air purification technology. Then you have, sorry, this was 62.2. This is for residential. For healthcare facilities is 170.1. For green buildings, 189.1. For healthcare facilities for sustainable buildings is 189.3. There's a guideline from ASHRAE. It's a 42P enhanced indoor air quality guideline for commercial institutional buildings which you can use. And in the last webinar, I talked about ASHRAE 241. That's the latest standard which came out, which is the one and only and the first of its kind standard, which is there for the control of infectious aerosols. So most likely this standard is going to be adopted into one of these 62.1 and 170. And the hope is that it can eventually get into a building code so that people are designing your buildings correctly and making sure that the buildings are designed to handle any other outbreak like COVID, which happened and buildings were not ready for it. So today the building code, the International Mechanical Code, is only following ASHRAE 62.1 ventilation rate procedure. There is some language for indoor air quality procedure as well, but primarily it follows ventilation rate. So there's work to be done. There has to be a link or tie into all these standards, linking IAQ to health benefits. There's a conflict between energy and IAQ. There's a focus on energy, and IAQ is secondary, but there has to be a good balance of energy. And I think all these solutions which I'm talking about, they do a fairly good job of this. This is, people who haven't seen this, this is the scope of the ASHRAE 241 standard, and I went over this last time. So the 241 standard says that, okay, you can achieve acceptable air quality to control infectious aerosols using ventilation, or you can have some air cleaning solutions like in-duct air cleaning systems. It could be in the ductwork, in the plenum, or it could be in the room using in-room air solutions, which I just talked about, or you can have pathogen inactivation. So air cleaning is capture, pathogen inactivation is kill. That's where the UV comes in, UV PCO comes in, and portable air cleaners with UV come in here. So you might have seen this, but basically the advantage of having solutions where you may not need a very high single pass efficiency, but as you increase your air changes and you're recirculating the air, you can increase your particle removal. So this chart shows that, okay, as you go from an air change rate of from 2 to 4, the time to remove 99% removal of contaminants goes down by half, from 138 minutes to 69 minutes, and so on and so forth. All right, so this is a slide which I showed last time. Basically, Pacific Northwestern Lab had done a study which basically said that there's an opportunity to reduce airborne transmission and achieve ASHRAE and CDC targets at lowest energy, carbon footprint, and cost if done correctly, and there's some guidance there. There was another study, a simulation study done by Shelley Miller at University of Colorado, where she showed that a UV solution in a duct the use of MERV13 and induct domiciled UV with baseline has the same effect as increasing outside air. So there are some advantages in energy as well, and you don't really need to bring in outside air. You can replace outside air with effective UVC air cleaning. So with that, I'm going to go to my summary slide. Again, highlighting that UVC is a proven and effective technology to reduce surface and airborne contamination. When combined with a suitable photocatalyst, UVC is proven to remove odors and reduce VOCs. Again, effective against wide variety of our microorganisms. It's a sustainable technology, green solution, and has the potential to reduce outside air requirements and having that energy benefit as well, which people were kind of shying away from it. So with that, Dave, I'm going to hand it over to you to answer some questions which the audience may have.
Thanks, Ashish. A lot of great information, and it looks like you, throughout the presentation, you've been answering a number of the questions. And I would like to really turn this into our time hall portion of today's program by addressing any other questions that are open. So please, those out in the audience, questions in your mind, type those in, and we'll either answer as many as we can today, or we'll get back with anything that's open. We do have a couple of questions that came in earlier. Ashish, we have one. What does TLV stand for in the odor threshold table? TLV.
Yeah, that's the threshold limit value. It's really a safety limit on what is the threshold above which that VOC is going to be harmful to your health. These are called threshold limit values.
All right, thanks, Ashish. We have a question on PCO. Does PCO work with both 185 nanometer and 254 nanometer UV?
PCO actually works with UVA, which is 365 nanometers, and UVC. There's been very limited data on the effectiveness of 185, but both UVA and UVC have been shown to be effective. The advantage of UVC is that you're getting the double benefit of not just getting rid of the VOCs and odors, but you're also getting air disinfection. So if your PCO system is designed right, you can get a double whammy, like a double benefit of both. 185 nanometer produces ozone, so I don't think you want to do that. So you don't want to create anything harmful by using a technology. So you would stick to UVA or UVC. UVC, of course, preferably because you can get the benefit of air disinfection.
Thanks, Ashish. We have a question on, are there different types of titanium dioxide? I was amazed to learn that it's used in all kinds of things. If you look on the back of your toothpaste, it's what I think provides the color white in the toothpaste. So I know there's a lot of applications. I'm not sure about the types, but you have a comment on that?
Yes, I do. So there's a particular crystalline form of titanium dioxide. So there are two phases. One is called a rutile and one is an anastase. So it's the anastase form of titanium dioxide, which is the one which is very effective for a photocatalytic oxidation. And of course, your particle size, it has to be a nanoparticle because you need that high surface area of catalyst. So the smaller the particle size and how that titanium dioxide is deposited, it's a powder, right? So it has to be deposited. How that is deposited on the carrier is really important. A lot of times people would use a binder, and then binder is just going to plug up all the holes and not giving you all that surface area you need. So it has to be done right.
All right, thanks, Ashish. Question on standards. Are there any in the air purification? Are there any current test standards?
So I can talk about, of course, for filtration, we have the ASHRAE 52.2 standards. That's for the MERV rating. For gases contaminants, there is a standard for induct. It's ASHRAE 145.2. That is to study the effectiveness of activated carbon-based technologies. Then there's another standard, which is, I would say it's coming out or it's just already been released, is 145.3. And I think 5, which are talking about electronic air cleaning technologies like PCO and ionizers and stuff as well, but inside a 2x2 duct. So these technologies, these standards are for 2x2 duct. For UV, there are two standards. For duct, one is 185.1, which is for air disinfection, and 185.2 is for coil cleaning. And there's a new standard which got released earlier this year, that is ASHRAE 185.3, which is for in-room evaluation of an air cleaner. So in-room chamber test, I think it recommends 1,000 cubic foot chamber where you can deploy any technology and measure the effect in-room, not in a duct. And there's another one which just came out last week, which is 185.4, which is to measure the effectiveness of UV devices for surface disinfection in a room. These are the ones I'm familiar with today. ASHRAE 241 has a standard, it doesn't have a standard. They refer to the standards which I just mentioned, the ones which are published, but that was before 185.3 was published. So now that 185.3 is out there, that could be used to measure the effectiveness of air cleaning systems in a room.
Great, thanks. You talked a lot about the portable air cleaners. What's CATER? I've seen that, and that's come up as a question. What does that mean, and how does that apply to what you've been talking about?
Yeah, CATER is a clean air delivery rate. It basically is a measure of how effective your. It's really not an ASHRAE standard. It's an AHAM standard, more for residential air cleaning. 185.3 is really the standard you need for buildings. But the CATER rating is really what is used to measure the effectiveness, general effectiveness of air purifiers. Now, there are CATER ratings for particulate contaminants. There's a CATER rating for gaseous contaminants, and there's a CATER rating for microbial. Gaseous and microbial are fairly new, I would say a year to 2 years old, but it basically tells you how effective it is and how you can use that CATER rating to size your room. Basically, depending on the CATER rating of your portable air cleaner and the size of the room, you can figure out how many air changes per hour the room air cleaner is giving you. If you have a target, say, of 5 air changes per hour, and your CATER rating is giving you only 2 for that room size, maybe you need 2 of those, whether you put it on the floor or you mount it on the ceiling or on the wall. So yeah, CATER rating helps you figure out how many air cleaners you need, what air changes per hour your air cleaner is giving for that room size.
Great, thanks. So it looks like there's some questions related to standards. With the discussion of PCO and UV, can you review safety standards for UV? And then is there anything specific for PCO?
Yeah, for UVC, primarily it's been 254 nanometer wavelength. So there's a standard for photobiological safety, which is IAC 62471, which gets into those details on what are the standards. But of course, for UV systems and air handlers, there are UL standards for electrical safety testing. So it's the UL 60335-2. That's the one which is been used to validate the electrical safety for UV systems. And I said 62471 is for your photobiological safety. There's couple of standards for upper air, UL 8803 and 8802, which have just come out in the past year, which you can follow.
Well, great. Thanks, Ashish. And it looks like we are getting close to the end of the time we have available today. And there are some questions that we haven't had a chance to answer, and we're going to make sure we follow up on any of those. What I'd really like to do is quickly thank everyone again for taking the time to attend. This really concludes our 3-part webinar series. As Ashish mentioned, we previously had one on coil cleaning, airstream disinfection. He touched those briefly again during this presentation as they apply to the terminology of air purification, and those are available on demand on our website, as well as blogs that we now have available with a lot of information. So if you'd like to get any more details, we can certainly follow up. Ashish has pulled up a list of our contacts, and we'd be glad to answer anything you have, or if you have customers you're working with that we can assist with. So with that, I'm going to close from my end.
Great. Thanks, Dave. And thank you, Ashish, for a really wonderful presentation. Thank you to everyone from joining around the globe. And as you can see on the screen, we've got the contacts for the team that you can reach out to for further information. We also have a number of resources on the website, everything from videos and blogs to spec sheets and explanations of everything from air purification to air disinfection to coil cleaning. And like we said before, everything will be posted within the next week. The two webinars earlier in this series on air disinfection and the other on coil cleaning are already available. And then this one, the recording will be coming out shortly. So thank you again for your attention and for letting us come and bring you this information. And we're looking forward to speaking with you all again in the near future. Thanks.